Hello, my name is Mr. Rich. We're going to be covering motor control and industrial motor controls today. So this is Unit 1, Day 1, and this is my contact information. And then we are on the 1st of November of 2024. Now our objectives: size branch circuits and feeders for electric motors. Next, size motor short circuit protectors and size multi-motor branch circuits. Our equipment, non-applicable. Tools, calculator, and materials, at least have a pencil and paper or a pen. Now, our brakes are from 150 to 210, 350 to 410, and 5 to 510. Now, we're gonna refer to some NEC. So these are some NEC codes that are gonna help us in selecting these devices, okay? First, 430.250 for full load ampacities for three-phase motors. 430.52 is for fuse selection and breaker selection. 310.16 or page 73 of our Uglies book will help us select AWG for depending on an ampacity, okay? Now, in addition to that, we have 240.6A, which will help us see the next size up for our breaker or fuse, which is very helpful. Now, this is our system here. We got the MSB, our main panel, and then we have here a 3-pole circuit breaker. So it is up to us to find out what amperage that breaker is going to be. In addition to that, we are required by code to have a 3-phase disconnect here. The disconnect will have fuse. So now those fuses is up to us to also find what fuse ratings we need. That will depend on the FLA of the motors. And lastly, let's kind of go over the service feed size of the wire. So now we have to find what wire size we need, depending again also on the full load ampacity. This here is your overload protection relay and your magnetic starter, which is important. Okay. So now let's also emphasize that we have a squirrel cage type motor for all of these. These are squirrel cage type. So the first thing we're going to do, we're going to find our FLA of our motors. So we're going to have to refer to 430.250 using the horsepowers and the voltage from our main. So now let's take a look at the table here. We have 5 horsepower. This is 430.250 full load current, 3-phase alternating current motors. We look at this column here. Now we have 5, and we're gonna go horizontally in this row till we hit 460. So the first one says 7.6 amps. So we're gonna go ahead and write 7.6 amps for our 5 horsepower motor. Next, we're gonna do 7 horsepower. So we don't have a 7 horsepower, but we do have a 7.5 horsepower. So we'll use that one. Then we're gonna go to the right, and then we'll stop at 460 volts. And it says here 11 amps. So we'll go ahead and write 11 amps. And last is 3 horsepower motor. That's the last one we need. So then again, we're gonna go 3 horsepower, and we're gonna follow horizontally until we hit 460 volts, and we're at 4.8 amps. So we'll fill in 4.8 amps. Now, step number 2, we're gonna find the feeder wire. This is the feeder wire that's feeding into the overload relay and magnetic starters. Okay? That's also going to your motors. So now we have to follow this formula here. So we're gonna go 1.25 times FLA of the largest motor plus FLA of the other motors. The reason we use the largest is because we want to avoid nuisance, meaning that there's a high overload current in rush current, okay? And it happens for a fraction of a second. So we have to account for that. Because of that, we don't want to trip a breaker or fuse if there's only a fraction of a second of inrush current. Now, using this formula, we're going to go ahead and multiply 1.25 times FLA of our largest motor. And here we have 7 horsepower, which is our largest motor. So now we're going to take out our calculator, and we're going to input that right now. 1.25 multiplied by 11 plus the sum of FLA of all other motors plus 7.6 plus 4.8, and that gives us a total of 26.15 amps. So here we're going to have 26.15 amps. Now then we have to use 310.16 here. So in our NEC we have to refer to 310.16. Since we're given these books, we're going to go ahead and use page 73 since it's a lot easier to use. So now here we have to look for 26.15. Now say these were outdoor motors at 167 degrees Fahrenheit using thermoplastic weather resistant nylon. So here it says 25 amps will be covered if this is used for outdoor locations. So now we go to the left here and it says we need minimum 12 gauge wire. So now 12 gauge wire will work for this situation here. This is THWN wire. Okay. Under the scenario, we are dealing with weather conditions. Now, next thing, find circuit breaker. So we're going to use inverse time. This accounts for many appliances being plugged in at once. Okay. So now we use the formula 2.5 times FLA of the largest motor. Now, where do we find this one? This comes from NEC 430.52. So now we're going to refer to 430.52 for inverse time breaker here. These are percentages, or in other words, our multiplier. Since we're using a squirrel cage, we are going to use 2.5, or in other words, 250%. So we're going to use 2.5 times FLA of the largest, and again, it's 11 amps. And we'll see what that gives us right there. Hey, it's Friday, we can do it in our head. I'm not gonna do it in our head. Here's the calculator. 2.5 times 11 gives us 27.5 amps. If we are not sure what the next size up would be, but we know it to be a 30 amp, this is where we refer to 240.6a. 240.6a is going to be in page 100 of your NEC. Here we have standard ampere ratings for fuses and inverse time circuit breakers. After 25 amps, we have 30 amps. So we will go ahead and select a 30 amp 3-pole breaker. So now we're finished with finding FLA, finding the feeder wire, finding the breaker. Now we're going to find the fuse for our 3-phase disconnect here. Similarly, we have to follow 430.52. That's 1.75 times FLA of the largest motor. Hasn't changed, so all we got to do is multiply 1.75 times this guy right here. This is going to give us 19.25. Referring to 240.6a, we have to use the next size up. So the next size up is going to have to be, just to be sure, 20 amp fuse. So we are good to use a 20 amp fuse. If you like, you can also use a 25 amp fuse to allow for some tolerance. Okay. There's 80% rule. For example, if you have 100 lights on a 15 amp breaker. 80% of that 15 is gonna give you 12. Running 100 lights in parallel gives you 11 amps, so you're within range. Now we selected fuse. So now we covered everything we need in order to make sure that we avoid any short circuit problems. And again, this is for short circuit ground fault protection. Thank you for tuning in.